Hi everyone, and welcome to Algebra 2, Chapter 2, Lesson 9, Absolute Value Functions, and this is Part 2. So we're going to look at some more complicated transformations. In the first video, we talked about what an absolute value function is, and we looked at horizontal and vertical translations. Now we're going to take a look at stretches and compressions and reflections. So let me just remind you a little bit of how to do those in a function. For a horizontal stretch or compression, you're going to be multiplying the variable by the reciprocal of the factor. So you identify what you're stretching or compressing by, you flip that, okay, and then it goes in where the variable is. So find the variable, put parentheses around it, just the variable, and then put your factor inside those parentheses. For a vertical stretch or compression, you're multiplying the function by the factor. So you put parentheses around the function, put the factor on the outside, and then you distribute it into each term of the function. Just be sure not to distribute into the absolute value symbols. That way you can tell what the vertical stretch or compression factor was. And it doesn't always work to do that. So you need to be careful about that. Reflecting across the y-axis, you're multiplying your variable by -1, and then reflecting across the x-axis, you're multiplying the function by -1. Again, being careful not to go into those absolute value symbols. So let's take a look at an example where we have to do one of these transformations. In example 3, we're asked to perform the transformation and then graph. So we're asked to reflect the graph of f of x equals the absolute value of x plus 2 plus 1 across the x-axis. Now notice I only have the regular parent function here. The absolute value of x plus 2 plus 1 would move it to the left 2 and up 1. So it would be right here. Now we need to reflect across the x-axis, which might be easier to do on your graph, but we need to come up with a function. So the x-axis is a vertical reflection. It's going across the x-axis. So it's a vertical change, which means that it happens to the entire function. So you need to put parentheses around this and put the negative on the outside. And then you can distribute to each term, the absolute value term, and then the plus 1 term. So I'll show you what that looks like. Here are my parentheses here. And all I did was I took the negative sign, I put it right in front of this absolute value symbol here. And then I multiplied -1 times +1 to get this -1. I was able to identify the vertex as -2, -1 because I changed the sign on this and I keep this number. So that's my vertex. So -2, -1. And I know it was a reflection across the x-axis. So notice how it's upside down from where the parent function used to be. So that is my new function. And the reflections can be easier to graph. But when you do stretches and compressions, I definitely recommend making a table of values. And that's what we're going to work on next. In example 3b, we're asked to stretch the graph of f of x equals the absolute value of x minus 2 vertically by a factor of 3. So first, notice this is again the graph of the parent function. X minus 2 is down here at -2. So that's where it is, but we're vertically stretching by a factor of 3. Now a vertical stretch, that means put parentheses around the entire function because it's vertical, and it's a stretch by a factor of 3, so I put the 3 on the outside, and then I simplify. So I'll show you what that looks like along with the graph. Here's my function with the parentheses. Now when you distribute that 3 in, you just put the 3 on the outside of the absolute value symbols, and then you also do 3 times -2 is -6. So this is our new function. Now, like I said, I definitely recommend making a table of values for this. I just picked any x values I wanted. I did -4, and I got -4, 6. So I graphed that point here, and then -2, 0, and then 0, -6, and 2, 0, and 4, 6. But you can pick any x values you want. Just as a side note, if there had been a fraction happening here, you'd want to pick ones that are divisible by whatever the denominator of your fraction is, because it'll be easier to graph. That's just a graphing trick that will always be helpful. Okay, so we have one last example. Again, we're working with a stretch or a compression. We're asked to compress the graph of f of x equals the absolute value of x minus 1 minus 3 horizontally by a factor of 0.5. Now, the factor is 0.5, and it's a horizontal compression. So what we need to do is write this as a fraction, which is 1/2, and then we need to find the reciprocal of that. We need to flip it because it's a horizontal change. So horizontal changes, you always do something unusual. This time we're flipping. If it's a horizontal translation, you're subtracting instead of adding. So there's always a little extra with a horizontal. Let me show you what that would look like. So I found the reciprocal, which is 2, and then I took that and just put it right next to my x. So I did 2 times x. Notice this -1 was not affected by that. It only affects right where the x is. Now, in order to graph, I always recommend with stretches and compressions making a table of values. It's easier for you to figure out what's going on instead of accidentally getting your vertex wrong, because right here the vertex looks like it's going to be 1, -3. That's not what it is, because this 2 affects it as well. So let me show you my table of values and my graph. I picked the x values, -2, -1, 0, 1, and 2. You can pick any x's you want. Again, just be careful that if you have a fraction here, that you would pick ones that are divisible by that fraction, by that denominator. Now, when I took them and put them in, this is what I did. So -2 times 2 is -4. -1 is -5, make it positive, and then 5 minus 3 is +2. And then I got all these points. So I did the same thing for all these x values. Now, when I graphed -2, 2, so -2, 2 was here, -1, 0 was here, 0, -2 is right here, and then 1, -2 is right here. So you can tell when you graph it that there's something missing in between here, that the vertex is going to be there, because then when you graph 2, 0, well, that's up here again. So you see it coming down and then you see it going up. And we can tell that the vertex is actually going to be halfway between 0 and 1 because it's symmetrical. So you can see the symmetry on these. So we know it's exactly halfway. It's actually at 1/2 -3. Is where that vertex is. Can be a little hard to find, and it's a little odd when you're graphing it because you really have no idea where that is, but that's what it ends up being. So let me know if you have any questions. I hope this was helpful.